Hello, this is Mr. Ezra. In the last video, we talked about how to solve quadratics where a is equal to 1, where the leading coefficient is equal to 1. We're going to add one extra step to that today. We are going to talk about how to solve quadratics when there is a greatest common factor to be factored out. So we'll have to talk about that. Um, as we go through this, you do have a copy in your packet of the guided notes if you'd like to follow along, or you can take notes on notebook paper. It is up to you. As we're solving by factoring, when there's a GCF, GCF stands for greatest common factor. Okay, when you think of a greatest common factor, first, I want you to start with the word factor. Remember, factors are things that multiply together to give you things that multiply, that divide evenly into your number. So factors of 12 are 1, 2, 3, 4, 6, and 12. Those all divide evenly into 12. The factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. I've done the math and they all divide evenly into 30. So if you think about all the factors of two numbers, the greatest common factor, which we shortened to just be GCF, is the largest or greatest number that is a factor of both. So 6 is a factor of both, so we'd say the greatest common factor is 6. We're going to think about that today as we're looking at our quadratics. Remember, standard form is ax squared plus bx plus c equals 0. Quadratics are going to have to still be in this form for this method to work. All right, so when a is greater than 1, when our leading coefficient, when the number at the front in front of x squared is greater than 1, we want to think about whether or not there's a greatest common factor. It should be the first thing that we think about. Is there something that is a number that, or something, number and variable, that can be evenly divided into A, B, and C, that goes into all three parts? And if we find that greatest common factor, we'll divide each term by that number, or by that greatest common factor. Okay. When we do this, you'll see that we'll put the greatest common factor in front, and the new trinomial, the leftover bits, will go into parentheses. And of course, it's still going to be set equal to 0, and after we get it set equal to 0, then we'll use one of the methods that we've already talked about to factor the trinomial like normal. So once we do this greatest common factor thing, it'll be just like the problems we've been working out already. So there's a little hint I can give you, maybe to help you out with this. When you see three numbers, and you know that it's possible that you'll have a greatest common factor, instead of thinking of the factors of all of them, just think of the factors of the smallest one. So in this case, we're looking at the factors of 2. And I want between 1 and 2, both of them divide evenly into all of them, but we'd never factor out a 1. That's unnecessary. So we're just really looking at 2 and asking, does 2 divide into 2 and 6 and 108? And you probably all say, oh, yeah, they're all even, so 2 goes into them. So there is a greatest common factor of 2. It divides into 2, 6, and 108. So what we're going to do is we're going to divide all of these parts by 2. And the 2 that we divide out goes to the front. And the trinomial that's resulting is going to be in parentheses, still equal to 0. So what is 2x squared divided by 2? 2 divided by 2 is 1, which leaves us with x squared. Positive 6x divided by 2 is positive 3x. And negative 108 divided by 2 is negative 54. Write that there. All right, so now, once we do this, I want you to understand that 2 is a factor. It's out front, it's there, it's not going to necessarily go away. We're just going to keep it out front in front of the parentheses. But from here, we see 3 terms. So we're going to factor this like we would normally, where we'll first say, well, x squared is going to give us an x at the front of both parentheses, in front of both binomials. And then we'll say, well, we need something that multiplies to give us negative 54. Now remember, to multiply to get a negative number, one of the things has to be positive and one of the numbers has to be negative. If we think about this, our goal is to get a sum of 3. So we can maybe be a little smart about this. If I know that I'm multiplying to get a negative, but adding to get a positive, my signs are going to be different, but the bigger number is going to have to be the positive number. So I don't have to list out all the possibilities. I can just list out all the possibilities where the bigger number is positive and the smaller factor is negative. And as we're going along, we might say, well, negative 1 plus 54 is 53. That didn't quite work out. What else goes in? 2 goes into it, so negative 2 goes in 27 times. Negative 2 plus 27, the sum of that is 25. That's our goal, remember, is 3, and we didn't get it. So what else goes into it? Negative 3 goes in 18 times. We add those together, we get 15. Didn't work either. And then finally, negative 6 and 9 go in. So when we add those together, we get positive 3. That is the winner, winner, chicken dinner. Since it gives us our middle term, we know we've got the right combination. Let's highlight that. All right. So now that we've done this, we're going to take that negative 6 and 9, negative 6 and 9, positive 9. We'll put that in, and these are our two binomials. Now, remember with the zero product property, we're going to set everything equal to 0, but we only set the parts that have an x equal to 0. And since there's no x next to the 2, we're not going to set that equal to 0 because there's no way to change this. It's constantly 2, but x minus 6 could be equal to 2, and I'm sorry, could be equal to 0. And if 2 times 0 times another number is equal to 0, then this would be a true statement. So we'll take the x minus 6, set it equal to 0. We'll also take the x plus 9 for the same reason and set it equal to 0. So basically, zero product property, any part that has an x, set it equal to 0. We'll solve both of these to get 6 and negative 9, and those are the two solutions. Now, if you'll remember, we'll list these out here. If you'll remember the way that we can check these, there's two things that we can do. First off, when you get to this point, it's a good idea to FOIL this again in your head or on a piece of paper off to the side. X times x is x squared. X times 9 is 9x. Negative 6 times x is negative 6x. And 9x minus 6x is 3x, right? And then negative 6 times 9 is negative 54. So it FOILs to give us the quadratic that we were trying to factor, right? So we know that we factored it correctly. And then when we get to the end, if we plug in these two numbers for x separately, first negative 9, do the math, we should get 0. We plug in 6, do the math, we should also get 0. So that's one way to check as we go along, and then at the end to make sure that we got the final correct answer, okay? Our second and last example today, I've gone ahead and looked at, remember I said if you've got 3, 9, and negative 54, you don't have to look at the factors of all of them for a GCF. You can just look at the smaller one. The factors of 3 are 1 and 3, and 3 happens to go into 9 and negative 54, so we know it is the greatest common factor. So what will we do with that 3? We're basically going to divide everything by 3. So I'll show that this time. I'm taking all these things, everything all the way across, and dividing by 3. And when I do that, the 3 goes to the very front. It's going to be in front of the parentheses, and everything else will be a little bit reduced. So we'll be left with x squared plus 3x minus 18. Still equal to 0. That equal to 0 comes down there. Okay, I'm going to factor this just like I normally would, which means I have to come off to the side, and I have to say, okay, well, what are the factors of negative 18? And again, since my goal is a 3, a sum of 3, I know that the smaller one needs to be the negative one and the larger one needs to be the positive one. That way I don't have to do negative 1 and 18 and positive 1 and negative 18. I know the bigger one has to be positive. So negative 1 plus 18 doesn't work. That's 17, not 3. Negative 2 and 9 don't work because that's 7, not 3. Negative 3 goes into it 6 times, and it looks like this is the winner. Negative 3 and 6 add to give us the inside term, 3. So the 3 is still out front, just hanging out there. We now have x minus 3 and x plus 6. So remember the x is going to go first, since that's our variable. And then what multiplies to give us the last term, but adds to give us the middle is negative 3 and 6. Now that we have these, we use the zero product property. set them equal to 0. Do that real quick. That gives us positive 3 and negative 6. So I like to come off and list out my answers here. Circle them up or box them up. I could probably make that a little neater there. All right, well, that is it for today. Just remember, whenever your leading coefficient is greater than 0, I'm sorry, this kind of got me. Whenever your leading coefficient is greater than 1, you're going to check for a greatest common factor. And just let me throw something else in there really quickly. Let's say we had x to the third plus x squared minus 3. Well, I'm not going to go all the way through this, but actually that's going to be minus 3x. I'm not going to go all the way through this, but I do want to show you that a greatest common factor can be a variable. I just thought of this. I wasn't planning on discussing it today. So really quickly, what divides into all three of these? Well, there's not a number bigger than 1 that divides into all, but they all have an x. They all have a variable. So we can divide that x to the front. X to the third divided by x is x squared. X squared divided by x is x. Negative 3x divided by x is negative 3. And then we can deal with the resulting quadratic. So we'll see some examples like that as well. So remember, greatest common factors can be numbers, they can be variables, or they could be both. We could see an example of both. So that's it for today. Hope that helps you understand a little bit better how to factor out a greatest common factor when they're there, when you're solving a quadratic by factoring. Have a great day, and I'll see you in class.